Hello. Today is September 25, a Tuesday, and I'm here to introduce a fascinating trending article from archives. Alright, let's dive right in. So I was digging through some old papers, and I found one that really makes you think about how AI brains work. Well, how they sometimes don't. Latent learning. Episodic memory complements parametric learning by enabling flexible reuse of experiences. The curl is the ARPSNIV 40,9.16,189. Yeah, it's a bit of a mouthful, but the core idea is super interesting. It tackles this weird problem with even the smartest eyes today. You know how you can tell an AI a fact, and it seems to understand it. But then it gets tripped up by a simple twist. This paper calls it a failure of latent learning. Latent learning is basically learning stuff that isn't immediately useful, but might come in handy later. It's like you walk through a new neighborhood just to explore. You subconsciously learn where the bakery is. You weren't looking for bread then, but a week later when you want a croissant, you know exactly where to go. That's latent learning. Eyes are apparently really bad at this. The paper brings up this famous example called the reversal curse. Imagine you train a language model on the sentence, Plato taught Aristotle. Okay, simple enough. So you ask the model, who did Plato teach? And it correctly answers, Aristotle. Perfect. But then you ask it, who was Aristotle's teacher? Logically, the answer is Plato, right? It's the same information, just flipped around. But the AI often messes this up. It might say something like, Aristotle was self-taught, or just make something up. It's bizarre. The model learned the fact in one direction, but it can't flexibly reuse the knowledge to answer a different question. The information is latent. It's hidden in there, but the AI can't access it. It only learned what was directly needed for its training task, which was probably predicting the next word in the sentence. Plato taught Aristotle. This is a huge difference between AI and how people learn. The paper argues this is a key reason why AIs are still so data-inefficient compared to us. So what's the solution this paper proposes? It's actually inspired by our own brains. They talk about how we have two complementary learning systems, whereas the neocortex, which learns slowly over time, building up general knowledge. That's kind of like the main parametric learning, where it adjusts all its internal connections. But we also have the hippocampus, which is responsible for episodic memory. It remembers specific events like a snapshot. It remembers that one time you walked past that bakery. This system is fast and flexible. The paper suggests we devise something similar, an episodic memory system using retrieval. In the tech world, this is often called Retrieval-Augmented Generation or RAG. Here's how it solves the reversal curse. When you ask the AI who taught Aristotle, instead of just trying to guess from its general knowledge, the AI first does a quick search of its memory, its database of experiences. It retrieves the original sentence it learned, Plato taught Aristotle. Then it puts that sentence into its short-term memory, its context. So now the problem becomes, given the fact that Plato taught Aristotle, who was Aristotle's teacher, well, that's super easy now. The answer is right there. It's Plato. By retrieving a specific memory, the AI turns a difficult learning problem into a much simpler problem. Why did the parametric model break up with the episodic memory? Because it felt like it was living in the past. Get it? Living in them and in all past experiences. Moving on. Let's think about how this could be applied in our daily lives. The paper gives a few ideas, and I've got some too. Verse and dialogue systems. Imagine you're having a long conversation with a customer service bot. On Monday, you mentioned your order number is 12,335. On Wednesday, you come back and say, I have an issue with my recent purchase. The standard bot would have no idea what you're talking about and would ask for your order number again. But a bot with episodic memory could retrieve the memory of your Monday chat. See the order number 12,345 and say, are you talking about order 12,345? That's a much smoother and more intelligent experience. Second, in information extraction and text summarization. Think about a lawyer or a paralegal researching a big case. They have to read thousands of documents. An AI could help, right? So the AI reads one document that says company acquired company B in 2020. Later, it reads a different document about a factory owned by company B. A standard AI might not connect these two facts. Automated retrieval could pull up the acquisition memory and understand that the factory is now effectively owned by company. This allows for a much deeper and more accurate summary of the situation. And a third example, machine translation. This one's a bit more subtle. Let's say the AI is translating a novel. Once that a character uses a specific idiom, like he always paints the town rain to mean he parties hard. Later, that same character uses a different but related phrase. A standard model might translate it literally and lose the meaning. A model with episodic memory could retrieve the context of the first idiom, realize this character speaks some colorful, party-related phrases, and choose a more stylistically appropriate translation that preserves the author's intent, which is really cool. Now, how does this compare to other technologies? Well, the standard approach is just parametric learning. The AI tries to cram every piece of knowledge into its network weights. It's like trying to memorize an entire library. You might know a lot of facts, but you'd struggle to creatively connect them. It's powerful, but as we've seen, it can be very rigid. Another approach is data augmentation. Solve the reversal curse. You could just train the AI on both. Plato taught Aristotle, and Aristotle was taught by Plato. You give it every possible variation. This works, but it's super inefficient. You have to anticipate every single way a question could be asked, and create training data for it. That's just not practical for the real world. The episodic memory approach is much more flexible. You just store the information once, and let the learning and its reasoning skills figure out the rest at free time. It's about learning to be a good researcher, not just a good memorizer. So to wrap it up, this paper points out a really fundamental weakness in current AI. They're great at learning patterns, but not so great at flexibly reusing specific knowledge. A way to look up past experiences. We can help them bridge that gap. It makes them more robust, more efficient, and honestly, a little more human. A fascinating look into building smarter, more flexible AI. What a concept.